This is the ROS Developers Podcast, episode 50 already. Yeah.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo Tellez here from The Construct, and today we are going to interview Zachary Allen. Zach is the CEO of a company that is called Slate Robotics. And it's an amazing company because they are building very affordable and very high quality mobile manipulators. And then today, Zach is going to tell us about his mobile manipulators, how they look, how they work, and how you can use them to create your ROS programs for testing anything that you would like to test on a humanoid robot with a mobile manipulator, for example. So thank you for being here at the podcast, Zach.
Thanks for having me, Ricardo. Really excited about this. Big fan.
Thank you very much. Okay, so you are listening to the podcast then?
Yeah. No, I've followed your website and YouTube channel. You've done videos like whenever I was first getting into ROS. I remember watching some of those, and then I came across the podcast just a couple days ago, and really excited. Really, I like listening to all those
great
interviews.
Great,
yeah.
You are on the podcast number 50. So that's a feat. I mean, that's a feat. So we have reached.
Big milestone.
Yes, and also an honor to have you here. You are one of the few companies building robots based on ROS in the world that we have interviewed. So basically, we usually interview more people about the software development. In this case, it's about your hardware.
Right. Yeah.
And yes, I can see that you are using the same mic I'm using here. I think,
Yeti Blue.
Yeah. Exactly. I can see here on the image. Okay. Anyway, so let's start with the question, because then maybe people get a little bit bored about our chit chat. Let's see. So then about what I mentioned before is that your company, it's called Slate Robotics. You are building their mobile manipulators, and the one that you can buy at present is called the TR2. It's not the PR2, it's the like TR2. So what is the TR2? Can you describe to the audience?
Yes, the TR2 is a human-sized robot development platform. A mobile manipulator, as you said. And it's the first one of its kind that's approaching a price range that mere mortals can afford. And so it's a robot. It has a camera. It has an embedded computer. It has a battery built in, a couple wheels on a mobile base, and a full robotic arm with a gripper attached to it. So you get all of this, all the platform, everything integrated for just under $4,000.
Yeah, amazing.
And so the whole reason for me starting the company was really, I was a software developer for 3 years. I was really, like everybody else, really interested in what's going on in machine learning, what's going on in robotics. I wanted to get into it. And, so I just thought, I'll go online and, I'll buy a robot so I can program it. And maybe I'll get it to, do some cool stuff around the house. Uh-huh. And, there's just, there were robots like this that are available, but they're $50,000 to $100,000.
Yes.
So I thought that was a shame. And, I thought maybe if I worked hard at it, I could try to build my own and start a company around that.
Okay, great, amazing story. That's the reason why you started this project, the TR2. And then in the TR2, we have a robot that contains a single arm, isn't it?
Yes, that's correct.
And then the TR2, it's indicating that there was a TR1 at some point in time. So,
Right.
So what's the difference between the TR1 and the TR2?
Yeah, the TR1 was so that was the first robot that I had built for the company. If you do some Google searching, you can find a little bit of information on that.
Yes.
But it had 2 arms. It was 7 degrees of freedom for each arm.
Wow.
And it was even bigger. It was like 5.5 feet tall. Anyway, it was a huge robot. It was a monster to try to manufacture. So we sold a couple of them, and it just had the worst time trying to manufacture them. And then, you would build it, and there would be all these debugging issues. So the design was just so complicated that it was just impossible to manufacture, and the reliability wasn't good. Didn't have the features I wanted it to have. So it was, about a year ago, I've been now at this for 2 years, so that for the first year it was TR1, and then I decided, this isn't quite what I had in mind. So, scrapped it. And, for the past year, we've been developing the TR2.
Okay.
And the TR2 just builds on top of the same kind of spirit, the same kind of idea of the TR1, but it's a little bit smaller, a little bit more practical. Shipping's a lot easier, and the design is way, way simpler.
Yeah.
We'll get into a little bit maybe later on in the show, but just simplified the design so much to where it's really, we put it together super easily, and then when we put it together, it just works. There's not this crazy debugging time and trying to figure out issues just because it's so simple.
Yes, of course, the control system is a lot simpler, and also the price is a lot lower because you are decreasing the number of arms, and also the structure that has to accommodate those arms. So I think so that's a very similar approach to the one that did this company that is called Rethink Robotics. Do you remember Rethink Robotics?
Oh yeah, definitely.
That's already gone, so it's dead now. But they built this Baxter robot, and then they built this Baxter robot with 2 arms. But then at some point in time, I don't know the reasons, but I suppose that also is to simplify. They created the Sawyer robot that was with a single arm. So it's kind of simplification in order to have more productivity at the end, because handling everything with 2 arms, it's a lot more complex. Maybe even we don't have the algorithms ready for that. And just to focus on 1 arm and doing it very well, maybe we can get better.
There's so much you can do with 2 arms. But, I'd rather have 1 arm that performs really well than 2 arms that don't perform very well.
Yes.
So that, we've lowered the price a little bit from TR1 to TR2 just because it's easier to manufacture, but we've been able to concentrate more resources per robot in just that 1 arm, rather than, let's say you have $2,000 to spend on an arm, and having to split that out between 2 arms, you can just put that in 1 arm. So the sensors are better, the microprocessors are better, the motors are a lot better, just more high quality, are going to last longer. So, I imagine down the road we'll start to introduce another arm back into it, and because I think 2 arms is important, but got to get 1 right first.
Yes, then if I have correctly understood, actually the price between the TR1 and the TR2 is about the same. It's about the same, but you have used this budget for the second arm of the TR1 in order to improve the quality of the single arm in the TR2.
Correct.
Okay, great. Related about what you mentioned about at some point in time, maybe you are going to reintroduce. Once you have mastered everything, and then you have a strong position with your single arm, maybe you are going to reintroduce the second. So that's the thing that the people at Par Robotics are doing at present. So they have a robot that is also a mobile manipulator. I would say that is a competitor of yours, but it's moving in the other scale of the one that you were looking for at the beginning for the robot.
Right,
so
exactly.
Very, very expensive. So now they are introducing a version of the robot with 2 arms also. So,
oh, cool.
So just to let you know, in case that you don't know, Maybe you can.
Yeah. No, I've followed them. I wasn't aware of that specifically, but they make some really cool robots. Yeah, I'm always excited to see their videos of what they've got going on.
Okay.
They're in Spain too, I believe, right?
Yes. Actually, they are here at some streets here away from.
Oh,
from
cool.
here in Barcelona. Okay, so let me ask you another question. Can you describe us the main features of the TR2? So, what is composed of, and what is thought for specifically? So people can see if this robot is something that it applies to them.
Right. Well, I think the number one selling point is that it's life-sized and that, it sits, it's about 4 feet tall, so it's not as big of a human, but it's tall enough to work off of tables. The arm's easily capable of doing that. So like the number one selling point, the reason you would buy this over something else, if you're a developer looking to get into robotics, it's because it's big and it's capable of doing things, a human would do at your house. I mean, that was the whole idea. So number one, it's human size. And then, obviously it's got a 5-axis arm with a gripper. It has a 2 degree of freedom head with pan and tilt, with an integrated RGBD camera, which means there's depth information in there. It's the differential drive mobile base, has a computer embedded in the system. It's an NVIDIA Jetson. The default option is a Jetson Nano. You can upgrade to the Jetson Xavier, and rechargeable battery. So this is, it's really all just one package. There's a switch on the back. You turn it on. You plug power in wherever you need to charge, and it's just everything's integrated. All you have to do is just either SSH into the robot to start programming, or you can hook up a HDMI keyboard and mouse and just program straight on the robot. So,
okay. Yeah. So, and then two things I wanted to mention about the specifications. So you mentioned that the robot is human size, so it can operate on the tables. That's very important because we need the robots to bring us the beer or clean the table. So that's the goal. And then another important thing that many people is asking usually to this kind of robots is if they can grasp things from the ground, things that have fallen out. So what about that?
Yes. Yeah, you can. It the fingers, are maybe a centimeter or two off the ground. So you can, if it reaches all the way down, so you can pick up a lot of objects like a shoe or something like that. You're not going to be able to pick up like a coin or something.
Okay, yeah.
But
that's too much.
The way the gripper's designed is actually, it's a rack and pinion setup. So the 2 fingers slide on these. I get which one's the rack and which one's the pinion. But there's a gear on the inside. The 2 fingers slide like that. So you can put your own fingers on there. So if you want more reach, you can put longer fingers. You just 3D print those and then bolt them into those little slide rails. In theory, you could pick up coins or something like that, or if you need something with a little bit more grip, you can put different material or put some paddings or something like that on there.
For different types of grip during the grasping, for the different types of materials. Yeah.
Right. Yeah, and if you're picking up a cup, you may not want 2 fingers that are squishing the cup like that. You might want something that, kind of puts a circle around it and lifts up like that. So I don't know if anybody will play around, any of the customers will play around with putting new finger attachments, but that's a possibility.
Okay, yeah. Well, by building that community around your robot that you are building, so some point in time, I'm pretty sure that some people of the community, they are going to start implementing new things for your robot, because your robot is, I don't know if the design of your robot is open source or is it closed design? Is it open source or is it closed?
So right now, everything is, all of the software is open source. So we don't have any of the hardware open sourced. I had thought about that in the past, but I think what I would do if somebody was wanting to print their own fingers or anything like that, we could give you drawings. I just see right now, the only people, like if I knew there were a lot of people like you and me that were just interested in like open source the design so I can build it myself. If I knew there were a lot of people, I would probably do that. But I think the only people that would really be that would find that valuable would be people trying to compete with us. See what's going on in the hardware. I don't know. I don't know if I'm correct about that, but that's the assumption I'm going off of right now.
Yeah. Of course, I completely respect that opinion, and it's very. It's very sound, your opinion about that. It makes perfect sense. I was going to suggest you the same way as the Turtlebot 3, for example, from Robotics, the Korean company. But they have open source, but of course, if people wants to build that, they will have to buy the components anyway. The servers and materials that they already sell. So so it's like an indirect entry of customers.
That's an interesting idea. Seeing what we have. Because we have proprietary control boards that have the microcontroller and driver and different other components built in. Maybe there's an opportunity if we open source the design, we can sell those components, and that would probably be an easier business model too, but we'll see. I'm just listening to whatever our customers or potential customers want, and just trying to make people happy.
Yes. Okay. And then another question is about the sensors that you have put on the robot. Then which ones are the ones exactly? You mentioned the RGB camera with point cloud on there, and which other sensors do you have on there?
I guess it kind of depends on what you mean by sensor, but there's
it's true.
There's encoders in the wheels, in the base, which is important for navigation. There's a voltage sensor, so you can tell when the battery's running low, and then in each of the actuators there is a absolute angle encoder, which reads up to over 3,000 pulses per revolution.
Do you have torque sensors?
Yes. Yeah. So these are this is my custom design that uses these absolute angle encoders, and by having a little bit of the design of the actuator is built in, so there's a little bit of flex. There's these pads that allow the actuator to just flex a little bit, and we read the position and the change in that flex of the actuator, and you're able to deduce based on how much force it takes to compress these little pads. You're able to see what the actual torque is that's being applied on the actuator. So that's a really cool feature of the TR2, is that we do have torque sensing built into the actuators. And
you mean on the gripper? You mean on the gripper?
Not on the gripper. We actually don't have force sensing on the gripper.
Okay, so I understood wrongly then. What do you mean the actuator? Which actuator?
Well, in the arm.
Oh, okay. The motors. Yeah. Okay.
Yeah, the 5-axis.
The joint. Okay.
Correct. Yes. So the motors themselves are not actually back drivable, but we're able to put it into back driving mode by reading the torque of the actuator. So you can twist on as long as it's in that back driving mode, you can twist on it. The actuator reads what the torque is being applied, and then it rotates in that direction. So that's a really cool feature, and there's probably a lot more we'll be able to end up doing with that. But that's another thing you don't really see with this kind of low cost robotics.
Exactly, for that price. Usually that's some features that are in the 20,000, 30,000 range for the robot. Price of the robot, exactly. I mean. Yeah. Wow, amazing. And then about the sensors, so for me, it's very important to have a laser on the robot, but you didn't mention, so why don't you have a laser, a LiDAR on the robot?
LiDAR. Honestly, I haven't looked into it much. I just know that generally those are kind of expensive. I'm sure there's some low cost options out there, but I always just assumed if somebody was really, I might look into that in the future and end up adding that to the product as a default option. But I always just assumed if somebody was really interested in having LiDAR, it's as simple as just, USB plug into the computer.
So,
and putting it on
we can just buy this sensor, for example, one Hokuyo laser that is not very expensive, and then attach some way to the base, and then attach the USB cable to some connectors that your TR2 has for that purpose.
Right. Yeah, definitely. If it's USB, it's super easy because there's just a USB hub in the actual base. You can just plug it in there.
Okay.
What kind of sensor was that? I can look it up and maybe.
Yes. So let me give you a couple of references. So it depends on different prices but different qualities. And And actually, I will do it after the interview. Okay. But there is one at Ross Components shop that is very low price, and actually is 360 degrees measurement of the laser around the robot. So maybe it depends on where you put it. It's going to detect itself also. But I mean, you can filter that. You can do whatever you want, and it's about, if I remember correctly, it's about $300. $300, around there. So I will give you that detail, and I will put also the link detail on the show notes for anybody that is listening and say, "Oh, yeah, and I'm looking for that." Okay.
Right.
Okay.
That sounds great.
I'm telling you that because for navigation, if you want to use a typical ROS navigation stack, then having a laser is quite useful. It's quite useful.
Right.
It can be done with the point cloud also, but it's more limited. It's more limited.
Okay.
To the range.
Yeah, that was kind of my assumption, is that you could do the navigation with the point cloud, but laser would be better. So maybe we can offer that as an upgrade. On the
exactly. As an upgrade, maybe for something else, like the upgrades in the different computer types that you provide, or the battery also that you provide.
Right. Exactly.
Okay. So let me see. Then see the questions that I have here. So that's something that is very interesting for me is who are you targeting with this robot? So what are your customers?
Yeah. Well, I can tell you the people that have bought this and have ordered TR2s, they typically have a machine learning background and they have some sort of interest in robotics. So it tends to be people who are like, they really want to do the software and they don't want to worry too much about the hardware. Tends to be who we sell to. I mean, there's a lot of people that are interested in robotics and they're really interested in the hardware. They'll just build their own. Just there's a few idiosyncratic people like me and perhaps you that are just for some reason have some crazy interest in robotics and just want the opportunity to play around with it themselves.
Yes, but exactly that target is very common. They are just interested in the software development, so in the artificial intelligence algorithms for the robot, and then having to take care of everything, also the hardware, then sometimes makes them feel a lot of pain. If you can provide this one, so then I would say that your main customers will be researchers.
Yeah.
So you're targeting them.
Right. Yeah, you could say, individual engineers wanting to do their own development, and then also small research institutions, because the big ones, they have the money, they'll go out and buy the high end stuff. But this is a group of people that typically wouldn't have access to a type of robot like this.
Yeah. Okay. Makes perfect sense. And then let me see. So about the main problems that you faced when developing this robot. because you think, okay, so I need a robot for doing my experiments, then I'm going to buy one. It's too expensive. Okay, so I'm an engineer, I'm going to do it myself. And then you start see all the problems that happen in there. So what happened to you? Can you explain us something interesting?
Yeah, I mean, when I started, I knew nothing. Like I was a software developer, so I had no background in mechanical design. I had no background in electronics or electrical engineering. So, when I first started, it was literally just walking around our local hardware store, walking around what can I use for my robot that I'm trying to build? Eventually I learned about 3D. Like, I didn't even know about 3D printers when I started.
Okay.
I was like, oh, there's these things called 3D printers. You can design out you can design out the robot in software and then print the parts. So I got really excited about that. And so that's ultimately, how we do a lot of the custom parts. Those are 3D printed now. So that was obviously I talked a little about the complexity of the mechanical design and the electronics, and that was a big problem, was just figuring out how to, okay, it works. That's not good enough. It needs to be simple. It needs to be reliable. So figuring out how to make the design simple. And, just starting a company like this is really, really challenging. It takes a long time to figure out how to get stuff to work. It takes a long time. The big thing is, like, you can have a prototype, and you'll see online people will build a prototype. Taking that prototype and actually turning it into a product is a really complicated process.
Yes.
Because when you build something out yourself, all of the idiosyncrasies of that robot,
and you adapt.
I can't. Yeah. Like, I can't do this thing because that thing will break it. So I'm only going to do this stuff.
Yeah.
But when you sell it to customers, they don't do that. They want the whole thing to work.
Exactly.
And they want it to be easy, and they want it to be reliable. So that's, often in my experience, because this is my second product now, it takes longer to go from prototype to, a full complete design that actually you can sell. That's a longer process than even coming up with a prototype.
Yes, that is right. That's so I have suffered the same thing in the past, and so the step from when you have the video that you can post on the internet. So the video, okay, so I'm doing this, so that's cool. Oh, that video is super cool. But I'm making that robust, that it performs in the same way every time. That was a customer once. That's why they buy your robot. That's another completely different story. Yeah.
Exactly.
So So I can feel your suffering, the one that you have been around in order to get the product done.
So do you have experience building hardware and
yes?
So
actually, I was working for this company, Slate Robotics, before I was working.
Right.
And there we have this problem all the time. Yeah. So because we build the prototypes, and then, okay, so it works. We have made the robot to move from here to there, but then next day you switch it on and it doesn't boot up.
Yeah.
Or I remember, for example, some errors with the batteries. So you have the battery, and then it, in theory, is stabilized enough for providing the power supply to the different electronics. But for example, we had one laser I think it was from SICK, I'm not sure. I don't remember the exact brand, but then this was small disturbances in the battery level because of the wheels moving, where they were changing just a little bit, and that makes the laser to get into a fault mode. You know, and that to solve that was like, first, to find it was very difficult. Second, to solve it, poof. And errors like that. Didn't you happen some things like that to you?
Yeah, even that specific problem, that the power supply not being able to supply power, everything's drawing at the same time. So I had a very similar problem. If the arm and the wheels were all moving at the same time, the computer would shut down.
Yeah,
because the computer, the voltage level drops too low, and then it just goes into fail-safe mode. And it took forever, especially not having a background in electronics, to know what's going on. Is that power supply, the battery itself wasn't capable of, delivering that much power.
Correct.
So, ultimately the solution there was taking these really big resistors and resisting some of the current to the arm, that if the arm is, drawing full power, that it doesn't draw so much power that it shuts the computer off. So, finding all that kind of stuff is just,
yes. That's frustrating and a lot of work and when you think that you already have it, and then you don't have it yet. Yeah. So
exactly.
I completely share your pain, really. And what about so my next question was, sorry, I got out of my mind. So let me come back to I wanted to ask you about the older parts that you have built, because I don't know on this robot. So you mentioned that you are using, for example, the NVIDIA Jetson board, and presumes that some cameras also that you have already bought from another company, from another supplier. And so how many parts have you built yourself in terms of electronics or mechanics? And how many have you already bought from somebody else, from a third party?
Yeah. I guess you could say most of the mechanical side is custom fabricated. We have a 3D printer, CNC machine. The design of the actuators, there's, it's reinforced with steel shafts that run through them. There's bearings. So, we'll cut the shafts to length. And so a lot of the mechanics we'll custom fabricate. The electronics are less so, but, we're slowly doing more and more on the electronic side too. Just when we come across stuff that, we want to do this, but the current offerings don't give us what we need. But things like the encoders, the motors, microcontrollers, we mentioned the camera, the computer, battery, that kind of stuff. We purchase those from suppliers and we'll put those in our robots. But an example is each actuator has its individual, and when I say actuator, I mean the joints on the arm. Yeah. Those have their custom control boards that a guy here named Tavian, he helped design, and those have integrated on the boards, the microcontrollers with the motor driver, and we actually take the motor driver chip now and we put that straight on the board. Before we were using these off the shelf motor drivers and trying to build that in there. So this just makes it cleaner. So I look in the future, I see we'll probably do a lot more on the electronic side.
In order to optimize, I presume.
Yeah, exactly. And, it really increases reliability too, because when we were buying motor drivers that, you'd buy off the shelf and then, you'd try to wire it all in the actuator. So we'd have these wires that were, going from the microprocessor to the motor driver, but then you have all these moving parts. Yeah. So wires, have a tendency to pull out of different places. So having that all integrated on the board is really cool. And it just means, we throw it together, we upload the code and it just works and continues to work for a really long time. So those are the kinds of upgrades we're looking at.
Okay. Yeah. The problem that you mentioned about the cables is very common. Because at the end, when you start to plug a lot of things from third parties, you have to actually plug them in some way. So by using cables, and then if it's if it's a robot that requires to move, like your arm, for example, then you have these problems of the length of the cables. In one situation is good enough, and another one is taking too much tight, and then or it's by the movement, the cables they are. I don't know how to say in English. It's like they are touching between the different parts. Right. So at the end, they break at the end. So,
Anywhere there's rub, and there's friction on those cables. If it's probably okay for a little bit, but at some point that's going to break into it, and there's going to be a short, and the cables are going to break. So, that's. Again, some of the joys of worrying about hardware.
Yes. Yeah. Okay. And then let's say we want to move away from hardware. Let's go to software. So
Yeah.
which part are you providing already in terms of software when somebody buys your robot and then it just takes out of the box and switches on? What is going to have? Sorry.
Yeah. So what you're asking
Software.
what we have available on the software side.
Yes, exactly.
Yeah. So we have a small kernel right now of software capabilities that are offered out of the box, and that's just going to keep growing and growing from here. Right now you can expect integration with ROS, obviously the basic description file, so you can do the visualization of the state. We have a Python library for the TR2, and also what I call it the TR2 node library that publishes and subscribes to different ROS topics. So you can fire up that TR2 node, and then you can go publish position commands for each individual joint to those ROS topics.
Okay.
So that's really cool. The idea that I have when you get this is that you turn it on, and then you just go into ROS and you publish a position command to a joint, and you can, right out of the box, within 10, 15 minutes, you can have this thing actually moving and controlling around like that.
And does it use MoveIt for
Yes.
publish? So can we use MoveIt for publishing the end effector position? So say let's grab this bottle that we know that is in this position on the table. So you just throw the position, the final position of the end effector, and then it goes there.
Yeah, exactly. Yeah, I'm actually right now working on the integration with MoveIt, and yeah, so that will definitely be available. There's a little bit more work to really optimize that and make sure that it the controllers get it to the position it needs to get to, and that because sometimes MoveIt can fail in the planning and tuning everything that way. But yeah, definitely that is something where you'll be able to get it up, open up a Python library and just call your end effector position function on the TR2, and the end effector moves to that position.
Okay, yeah, that would be cool because it simplifies a lot the work for making the robot reach some object on the table. So you just say, oh, the object is there because I have detected with my detector system, and then it's 1 meter in front of me, so I'm going to move the arm there. And by the way, what about the perception? So the cameras, they are publishing also in ROS topics?
Yeah.
So we can get the data.
Correct. Yeah. So the actual camera is called Orbeck Astra, and they actually have their own ROS libraries for that. So those come pre-installed on the TR2, and then those publish all of the image and depth cloud or point cloud data.
Okay. Awesome. And then what about ROS 2? So you are using in the robot, you are using ROS 1, isn't it? Which version?
Yes, that's correct.
Which version?
Kinetic.
Kinetic. Okay. Yes.
Correct.
Yes. We are all still in kinetic, Yeah. All around the world, we are in kinetic yet. So very, very few people have changed in companies. I mean, change to melodic. Very few.
Yeah, and all I'm doing is just whatever the customers want. So right now I don't think there's really much opinion, as long as you can kind of tap into the ROS ecosystem, and you can use MoveIt and all that kind of stuff that you want. I was looking at, and maybe you can help kind of. So the differences between ROS 2 and ROS 1, I was looking up some of the differences. They don't look like big. They look like more kind of under the hood. How it works in the back end, and improvements to that. Is there much feature improvements? ROS 2.
It depends. It depends on what you want. For example, in your case, one of the features is that you can have real-time control. That's very cool. but maybe you don't need, in your case, you don't need real-time control. So if you don't achieve real-time control for your arm, I don't know which kind of application will require that your arm has real-time control, and if something goes wrong, nothing is going to happen to the robot, actually.
Right.
For example, if you have a walking biped and then you don't meet the real-time control requirements, then the robot is going to fall. So that's very important in that case. And some other machines that are in industrial environments may also require. But in your case, I don't think so. Another thing is, for example, it's about the not having to have, with ROS2, you don't need to have a ROS core. So, so if that fails, then if the ROS core fails, then the whole system is down. In ROS2, you don't have that problem. So every node is independent, and then every node can fail by itself, but the rest doesn't get affected. You know, so that in your robot also doesn't apply. I mean, that would be cool, but not a big deal. And then the other thing that maybe is more affecting your robot is in terms of security, because now you can, anybody that gets into your Wi-Fi of your robot then can control your robot.
Right.
Yes. Anybody can see the topics. If it's on the same Wi-Fi, I can set on my computer the ROS Master Yuri pointing to your robot that is on the Wi-Fi.
Right.
And then I can see all your topics or control your robot and kill programs or whatever, kill nodes.
Right. Yeah, I saw a paper a long time ago where some researchers basically just browse the I can't remember what the default port is for ROS, but they just scanned the internet for systems that had this port open for ROS, and they found like 80,000 robots that were like just publicly accessible on the internet. So I know on our robots, because I have a bash script that it's just a basic install script. It goes in, every time I get a new order, this installs on all the software. So I have I basically close that port off to connections from the internet,
external connection.
But that's really cool that ROS2 has that safety built in at a lower level. So that might be a big enough reason on its own.
Yes. So I think that's the one that applied most to your robot at present. And then I don't know about any other better issues. I'm still in an early state about ROS2, so no super expert on that, and I cannot tell you by detail. But those are the main things.
Yeah, that's great.
Okay, and then so you just one question. You mentioned that there is a gazebo simulation for your robot, so we can use it.
Yes,
so people can download it.
Yes, it's not on our GitHub yet. It's still in the works, but I had built this out for the TR1. Yeah. So I've done this before. With this, and I've had success with it. It should be available in the next week or two. So right now, if you just follow us on our GitHub or follow us on our social media, I'll have that posted. But like I said, I have the description file, which is really the hardest part. The URL getting Gazebo to work, and then it's just a matter of tuning kind of the controllers of Gazebo and getting it to behave like the actual TR2 behaves. Yeah, but that's really cool because then people can download that and can play around with the robot before even buying anything.
Exactly. That's why I was asking for that, because I would like to put a link in the description, in the show notes for your simulation, so that people can start downloading your robot and start programming it. So what I'm going to do is to put a link to your Git, and then since you are going to publish there the Gazebo simulation, so they can go straight from there. So if you are listening and you want to get the simulation of the TR2, then go to the Git that is here beneath the notes, beneath the podcast, and then go to the Git, and then you will see his simulation there.
Yeah, depending on when you publish this, I can have it.
Exactly.
I can have it up by then.
Exactly. Great. And then let me check my questions. I think I have everything in there. So yes. So I think we have covered almost everything. The last question that I wanted to ask you is if you're going to attend by any chance to the ROSCON this year.
When is it?
When it is in October, I think by the end of October, I don't remember exactly the date.
Oh,
and
okay.
it's in Macau, in China.
Oh, okay. Probably not. I honestly, the biggest problem is just taking off that much time from work and trying to, I've got orders and stuff to get out. But I can't wait in the future to be able to go to stuff like that and kind of show off our robot and meet other people like that.
Yeah, that would be super cool to see your robot in real life there at the ROSCON and see how it behaves and how it shows. So
but maybe next year.
Maybe next year. Okay. I don't know where is the next year. I think it's in Europe.
Okay.
But I'm not sure. I don't know. Okay, we'll see.
Yeah.
Okay, so that is all from my side. Thank you very much. Really, thank you very much, Zach. Thank you for being here.
Yeah. Thanks a lot, Ricardo. Yeah.
Okay, and for all the listeners, let me remind you that if you want to learn to program robots with ROS, then you should have a look at the Robot Ignite Academy. We have created the 30-70 teaching method, which is based on 30% of the time learning theory and then 70% of the time practicing with simulated robots. We provide a complete path for beginners. So you can start by learning about Linux and Python for robotics. And then we continue with the basics of ROS. And we end with a course that makes you build your own ROS robot step by step. Have a look at the link. It's www.robotignite.academy. I will put a link here on the show notes. So that is all for today, ROS developers. See you the next week with a new lesson from the experts. And until then, keep pushing your ROS learning.
The ROS developers podcast. The ROS developers. The ROS developers podcast. The ROS developers.